AMS 101 Poster Presentation 611, an explanation for the observed increase in Atlantic hurricane and named storm activity. Conor McMenemy, nice research, Edinburgh. Here is the original poster. This presentation evolved from a search for test sites for a patented energy turbine for sea and river currents. The River Nile in Egypt seemed useful, but after investigating its flow data, it became apparent that there were some serious issues to be looked into. A subject we will come to soon, since it will help to explain the observed increase in Atlantic hurricane and named storm activity. The area of the Atlantic where hurricanes and named storms originate is specific to a relatively small area of the West African coast in months where the Intertropical Convergence Zone, ITCZ, has moved north of the equator. Scrutiny of the sea surface temperature in this region, which we will refer to here as the summer sea, demonstrates an exceptional surface warming effect centering to a July-October window, most of the warming happening off the West African coast, diminishing westward over an area near equal to the landmass of the USA. Of note is that this warming effect manifests itself northwards against the Canary Current. This additional surface heating event provides additional fuel to energize storms and hurricanes. Analysis of the summer sea surface temperature correlates nicely with a reduction in the solar reflective cloud mass above, allowing up to an additional 400 terawatts of solar radiation to be absorbed, causing the observed increased surface temperature. Satellite imagery of the ITCZ-related weather systems define the smoking gun for this event as variability in African easterly wave marine stratocumulus cloud. This becomes the principal agent for producing the large-scale ocean warming event with all of the attributes of the summer sea in respect to time frame, location, magnitude, and vector. Satellite imagery can be used to backtrack the African easterly wave system eastwards across the sub-Saharan continent to the Ethiopian highlands. Analysis of rainfall patterns across the sub-Saharan or Sahel region demonstrates that from the mid-1960s there had been a sequential reduction in the rainfall across a large swathe of the continent covered by the African easterly wave system. This reduction helps define not just the increased summer sea temperatures and hurricane strength frequency, but also the growth of the Sahara Desert in the last century. Unfortunately, historical meteorological data becomes thinner the further back we look, but fortunately the River Nile can be used to provide some degree of clarity in respect to African easterly wave activity going back to 1870. Given that the ancient annual July to October Nile floods stem from the rivers Atbara and Blue Nile, whose flow is determined by the current rains on the Ethiopian highlands, and those current rains correlate directly with African easterly wave activity. The September-October Nile flow at Aswan, shown here, is thus partly indicative of African easterly wave activity. It can be seen that the Atbara and Blue Nile flow reduced significantly at the start of the last century, then again from the mid-1960s. These reductions coincide with the construction and enlargement of the Aswan Dam complex on the Egyptian Nile. The improbable question arises, can the Aswan dams be affecting the rainfall 2,000 kilometers south? Given that the dams were built to partly control the flood, then from 1964 to completely contain the flood in a deep water reservoir, the seemingly impossibility of the dams controlling the rainfall begins to gain substance. This chart of moisture import into the Ethiopian highlands shows a profound difference in its meteorological makeup before and after dam construction. The 26,000 square kilometre warm, shallow, opaque, flooded area of the northeastern Sahara Desert, produced by the current floodwaters during midsummer, released about 4,000 cubic meters of water evaporated per second. To avoid any confusion, that means 4,000 tons of water evaporated per second. This flood evaporation would be pulled southward, periodically rising up on the northern slopes of the Ethiopian highlands, incepting the ITCZ-driven easterly monsoon to create a current event, providing the rainfall which had engorged the flood. Thus, the link between AS1 flood management, current rainfall, and African easterly waves. Those same current events drawn westward matured to African easterly waves, eventually producing the USA-sized cloudscapes over the summer sea. No more Nile floods means fewer current events, thus less African easterly wave marine stratocumulus cloud cover over the summer sea, allowing for a warmer sea surface, resulting in more hurricanes and named storms. Thank you.